Good evening, everyone. I'm KARK4 Chief Meteorologist Keith Monahan. Over the next 30 minutes, we're going to be talking about severe weather in Arkansas and how to keep you and your family safe.
And I'm Fox 16 Chief Meteorologist Jeff Baskin. We all know how quickly the weather in Arkansas can change and just what a large variety of weather we have. It's important to know how to stay safe by knowing what to do when the weather turns dangerous.
Keeping you and your family safe when the weather turns dangerous in Arkansas takes some planning.
Tonight we take a look at one of nature's most dangerous weather events, the tornado. Meteorologist Pat Walker tells us more.
Well, we know tornadoes can and do happen any time of the year, but now we are in the spring season, and that really is high time for tornadoes in Arkansas. March, April, and May are the peak months for tornadoes here in the natural state. Of course, there also is another peak going into the fall and right before the winter season starts up. And we also know that tornadoes typically happen in the late afternoon and early evening hours, particularly around this same time, around 6 p.m. or so. We really see most tornadoes actually happen in the state. And how do tornadoes actually form? What really gets it going? Well, you've often heard warm air and cold air meet, and that's when a tornado forms. If that were the case, well, every time we open up the refrigerator door, we would get a tornado, right? Well, obviously there are a few more variables that go into play rather than just warm and cold air meeting up. But where warm air and cold air start meeting up, they start forming areas of low pressure in between there. Also, when you have a very strong jet stream flow, that will help those areas of low pressure form. That area of low pressure is the storm system. That starts moving in to Arkansas and usually has a cold front with it too. And that cold front will start initiating thunderstorms. Thunderstorms have to have something to get them started. And down on the ground, we have that warm, humid air coming in from the southeast. We start having wind as you go up through the atmosphere at different directions, and that creates shear. Shear is a big ingredient in forming those tornadoes. You get a southeast wind at the surface, a few thousand feet up, you get more of a south or southwest wind, and then more of a westerly wind in that jet stream flow. And what that does is really starts taking those thunderstorms that formed with that cold front and starts helping those thunderstorms start spinning and growing even more. And that spinning of that thunderstorm forms the mesocyclone, meaning an area of rotation within that storm. And when we're looking at the radar and we say this storm shows signs of rotation, that's what we're looking at, that mesocyclone. We typically can't actually see the tornado, but it's that mesocyclone within that thunderstorm that produces a tornado on the bottom side of it, down on the ground, and then that's when we get that tornado. So you got to have that cold air, warm air meeting up, a storm system, and also all those different wind directions and wind speeds throughout height, and you get those tornadoes to form. Now, of course, our stats for tornadoes, most tornadoes aren't the big strong ones, EF4s and EF5s with winds of 190 to 200 miles per hour. Here in Arkansas, most of our tornadoes are those weaker ones, less than 100 miles per hour, typically around an EF1. I'm meteorologist Pat Walker for the Arkansas Storm Team. Now back to you.
Although tornadoes are the most talked about severe weather event, thunderstorms produce other threats,
Such as damaging winds and hail. Meteorologist Natalie Walters has more.
Hey everyone, in order for a thunderstorm to become severe, it has to have certain criteria. Either one of these is what we're going to be talking about here. Hail has to be greater than 1 inch in diameter. That's quarter-sized hail, so very large hail. Also, taking a look into the winds. Winds have to be greater than 58 miles per hour, so some pretty strong wind gusts with that as well as the possibility of a tornado in that for that thunderstorm to be severe. So we're going to be looking at the hail and the damaging winds with your severe thunderstorm. So let's get into hail and how hail forms. Now we see the hail. If you cut open a piece of hail, you're going to see little rings around it. So how this forms is every thunderstorm has an updraft and a downdraft. You have that cool air at the top of the cloud for us here, and inside that cold air what you're going to have are little ice crystals. What happens is that ice crystal ends up circulating within the cloud with that updraft and downdraft before it becomes too heavy and ends up sinking to the ground. So that's how hail forms, and of course hail can become very large and cause significant damage to your home, your car, to yourself as well. So important to take shelter when we do have a storm with some very large hail. Also talking about the damaging winds, you have that cool air inside of the cloud, so we always learn warm air rises, cool air sinks. When you get the damaging winds, that cool air basically sinks, pushing downwards, outwards in all directions, causing what we call straight line winds, and easily could become over 58 miles per hour, which would make a severe thunderstorm. So important again to take shelter whether you have that large hail or damaging winds in a severe thunderstorm.
Thanks, Natalie. You know, tornadoes and damaging winds aren't the only threats from thunderstorms.
There is a much more frequent threat, however, and it's the thing that causes a thunderstorm to, well, be a thunderstorm. Of course, I'm talking about lightning. Meteorologist Matt Peterson takes a closer look.
Well, we're going to discuss lightning now. It's what makes a thunderstorm, of course, and it's kind of one of our forgotten dangers within severe weather. Most of us know about the tornadoes, we know about the hail, we know about the strong winds, but what we forget about is lightning, and it's a very dangerous topic. It's a very dangerous phenomena that we need to worry about as thunderstorms develop here across central Arkansas. So we're going to be discussing the types of lightning and also how it forms within thunderstorms. So first we have our typical thunderstorm cloud. This is kind of the early stages of the thunderstorm. It's not totally developed just yet, but we're starting to see that anvil at the top. We're getting some low level convection, some turning in the atmosphere as this comes together. And once it gets a little bit more mature, we're starting to see the rainfall. You can see that true kind of anvil shape within that more mature thunderstorm. And as it again starts to see a little bit of rain falling, we see some hail developing within the cloud itself. We start to see a change in charge. We get some positively charged, some very light particles on the top side of the cloud and on the top side of the thunderstorm. And we get some heavier particles, some negatively charged particles down near the bottom of the cloud. And what we're going to be talking about first is what's called a negative strike. There are the two types of lightning. There's the negative strike and the positive strike. So we're going to be talking about the negative strike first. What we need to again think about is that the lower part of the cloud, it's a little bit heavier. There's a little bit more rain within that part of the cloud. So that's why we have the negative charges there. And the ground is a positive charge. So when we have that kind of static electricity, that's what we're going to be seeing form the lightning, which is just really one big spark, one big area of static electricity that is just very dangerous and very powerful. So what we're going to be watching is on the one side of the cloud here, we can start to see a grouping of that negatively charged particles. So they're starting to come together. They're again rubbing up and down against one another pretty decently. We're seeing more and more of that negative charge. And we're also then seeing down on the ground a conglomeration of more positively charged particles underneath that area of negative charge. So as we get to start to move again a little closer even to the ground, we have two different parts of the lightning strike when we have this negative strike lightning. We start with the part that goes from the cloud down towards the ground. This is called the leader. And really what we're seeing here is areas of negative charge getting closer and closer and closer to the ground. So it starts at the cloud base and again moves closer and closer down to the surface. And again, that's called the leader area. And that part, again, very dangerous. But then what we're actually seeing then from the ground up to the cloud is what is called the streamer. And again, that's when these two things come together, these two areas of electricity, the leader and the streamer, when they touch together, that's when we have our very first cloud to ground lightning strike. And again, this is called the negative strike because it's a negatively charged electricity in the cloud going down to the ground. And these are very dangerous, but they're actually not quite as dangerous as our second type of lightning, and that is called the positively charged lightning strike. So as we take a kind of wider range picture here, you can see at the top of the cloud, we always had those positive charges up there, and they're a little bit lighter. They're a little bit maybe even more powerful than some of those negative charges. And as they come together in the northern portions of the cloud, the upper air portions of our thunderstorm, we're going to start to see this area of electricity kind of branch out in the anvil. Usually we get these positive strikes towards the end of our thunderstorms. Usually they happen as the thunderstorm is already fully mature, it's starting to actually dissipate a little bit. And what makes these so dangerous is they can actually strike 10, even 20 miles away from the actual thunderstorm itself. So we have our positive charge up in the top of the cloud, and we have our negative charge now down on the ground. And you can see it's really far away from our cloud base. So here's the cloud base. We're all the way over there with our negative charge, positive charge in the top portion of the cloud. And as we put this in motion one more time, you can see our bolt of lightning goes all the way from the top of the cloud, again, 10, maybe even 20 miles away from where the actual thunderstorm is. So that's what makes these so dangerous is, again, the fact that we're striking very far away, and it also has the potential then to start forest fires because there's no rain. Usually when we have our negative strikes, there's a lot of rain, there's a lot of wind, and it really tends to keep those fire dangers low. However, when we strike so far away from where the precipitation is, that's where we get, again, the forest fires, and usually it tends to do a little bit more damage on houses, and even could be a little bit more dangerous to people as well as we get into these positive charges. So that's the two types of lightning that we have in severe thunderstorms. It's something that we need to remember, and hopefully this was able to explain a little bit of that to you.
There are many ways that you can get the information you need to keep you and your family safe.
With today's technology, there's no reason anyone should ever be in the dark when it comes to severe weather. Meteorologist Kira Miner tells us more.
Springtime is known for its warm temperatures, but as we look ahead to April and May, we also need to be aware of the threat for severe weather. As meteorologists, it's our job to keep you informed about hazardous weather conditions moving into the area. But what if you can't be by your television to get those advisories and warnings? Nowadays, weather information is right at our fingertips with smartphone apps and mobile weather alerts. But there's nothing like having a NOAA weather radio to wake you up in the middle of the night when severe weather threatens your county. At a moment's notice, Arkansas can see all types of severe weather ranging from flash flooding to tornadoes. Having one of these small desktop devices in your home can be a lifesaver. And the best news is they are relatively inexpensive and will continue to work even during a power outage. If you're an outdoor enthusiast, they can make great portable devices that you can take with you on your hiking and camping adventures. Once these NOAA weather radios are programmed correctly, you'll receive continuous weather information directly from the closest National Weather Service office, which includes severe weather watches, warnings, and forecasts 24 hours a day, 7 days a week. With severe weather season upon us, now is the time to make that small investment in a NOAA All Hazards weather radio. It could mean the difference between life and death.
Coming up next, watches and warnings. What do they mean and what is the difference?
Meteorologists Matt Peterson and Kira Miner talk weather on the Arkansas Storm Team's Severe Weather Special.
Confirmed tornadoes touchdown.
Now is the time to take shelter.
It was at least 3/4 of a mile wide. We just saw all this debris flying at us.
Severe line of thunderstorms headed this way.
We had plenty of warnings. We knew it was coming, and it saved our life.
Significant damage, structures destroyed.
Go into your safe place and do not come out. We have our reporters out there.
So we're beginning to see more of the damage out here.
Destruction this time is worse.
Good Lord was looking out for us.
We're activating the Arkansas Storm Team on KARK4 and Fox 16 because of a tornado warning.